Okay gang, this is the start of our next little topic. So before we were doing sort of kinematics, so looking at the way that things move, now we're going to be looking at forces, which is very closely related but is a different topic. So forces is really about what causes motion really. So all I want you to do to start with is just have a little think about what forces you already know. So you can pause and have a little think, see how many you come up with, and then compare them to my list that I'm going to share with you. So my list of types of forces is going to start with contact forces. So basically this is a force when you have two objects touching each other. So my hands pushing against each other, that's going to be a contact force. There's actual contact between the two objects, so they push directly. There are lots of different forms of contact forces, so it's probably actually going to be the most common, and some of the other types will actually also be contact forces as well. So next up is friction, which includes air resistance and drag forces. So basically this is when sort of two surfaces are moving relative to each other, which obviously is going to be a bit of a contact force as well. Next up is tension, which we will talk about quite a lot actually. So tension is caused when a body is stretched. So if I stretch an object out, it wants to pull back in on itself, and the pulling back is the tension. Then we've got compression, which is the opposite. So when I squash something down, it wants to push back out and be its original shape. So that would be the compression. Next we've got fluid upthrust. So we will talk about this a little later because we are going to talk about upthrust and the Archimedes principle explicitly a little bit later. But basically this is the force exerted by upwards by a fluid because an object with weight has displaced some water. Then we've got electrostatic forces, which can be either attractive or repulsive, and they just are due to bodies being charged. And actually, most contact forces kind of boil down to being electrostatic anyway, but don't worry too much about that. Next up is magnetic. Again, these can be attractive or repulsive, and they are in fact due to moving electric charges. So the difference between north poles and south poles is to do with the way that the electrons are spinning. Which is why, as you will learn next year, electric and magnetic fields are very, very closely intertwined. Sorry for clanging. My chinchillas are a little bit excitable this evening. Okay, so that leads us to electromagnetic. As I hinted, electrostatic and magnetic can join together. We end up with electromagnetic. So this is due to these can be both attractive and repulsive. They are due to bodies having charge, and as I intimated, contact, friction, tension, compression, fluid upthrust, electrostatic and magnetic forces are all basically just forms of electromagnetic force. They are all really kind of the same thing, but we have different names for them just to try and keep things clear. So electromagnetic is what we call a fundamental force. Next fundamental force, which we won't meet again until partway through next year, is called the weak nuclear force. And all you will need to know about this force at any point is that this is the force that's responsible for nuclear decay. Okay, and our next fundamental force is the strong nuclear force. So this is one of the other fundamental forces. And this is the force that's actually responsible for holding protons and neutrons together inside of the nucleus. Because I'm sure you all instantly thought that the idea of an atom is crazy, with all those positive nucleons, those positive positrons all smushed together in the middle. Why would they ever do that? I mean, you must have all been wondering why they stay together. And the reason is because there's something called the strong nuclear force that holds them together. Again, we're going to look at that in quite a bit more detail next year. And our final force is another fundamental one, and it's the gravitational force. And this is the force exerted on a body due to its mass. As I said, this is a fundamental force, and it can also be considered as being the weight. So the weight of an object is equal to the gravitational force acting on it. And for most situations we look at where we're interested in using gravity, we will use gravity as being 9.81. So that means that if we wanted to calculate the weight of an object, we would do the mass times 9.81. Now, I've just said we can calculate it, so that means that it's got to have a unit, and I'm sure you all know that we measure forces in newtons. But, do you know what a newton is? This is a real question. I'd be very impressed if anyone did know. But this is one of those definitions you are just going to have to learn, and definitions are going to be a really good way to pick up easy marks in the exam. So you're going to want to start learning them now. And in fact, once you've got a few of them under your belt, they may become one of those things that I ask you about at the beginning of the session. So the definition for a newton is as follows. 1 newton is the force that will give a 1 kilogram mass an acceleration of 1 meter per second squared in the direction of the force. So pretty straightforward, hopefully. Be aware this is the definition for a unit, not a quantity. This is not the definition of a force, this is the definition of a newton. And all our definitions for newtons are going to have sort of some similarities to them because they're going to be 1 of 1 of 1. So this is 1 newton gives 1 kilogram an acceleration of 1 meter per second squared. You'll see that theme going through for all our unit definitions. And the next thing we need to be able to define or state, this would often be a state, but still same thing, but could be worth up to 2 marks, is Newton's first law. So Newton's first law is as follows. A body will remain at rest or move with a constant velocity unless it is acted on by a net external resultant force. Okay, so basically nothing changes unless there's a resultant force. So just to be clear, constant velocity means constant speed going in a straight line. So that should be pretty straightforward, hopefully. So just some examples of Newton's first law of motion. So here I've got someone pushing on a box, and this moment the box is stationary. And the box will only move if the pushing force is greater than the friction force. Or the other option is that the box is moving, and the push force is exactly the same as the friction force, so there is no net force, so the box just moves forward with a constant velocity. My next example of Newton's first law of motion is the coin card trick thing. So we've got the coin on a piece of paper above a tumbler, and you pull the piece of paper out. So if you pull it out fast enough, basically the coin just drops straight into the glass rather than pulling with the piece of paper. And that's basically just because the force of friction is really, really small. So there is basically no net resultant force acting on it to the side, so it just drops straight down because of gravity. Okay, so that's Newton's first law, which you really need to know. The second law's coming up in a minute. Just gave the game away, didn't I? Anyway, so I just want to define gravitational field strength because I've already mentioned it once, and it is something that will come up later. So gravitational field strength is just equal to the force acting on 1 kilogram. So gravitational field strength equals force divided by mass, which is basically exactly the same as saying weight divided by mass. Just something to be aware of, because if you haven't got clearly in your head that weight and mass are different, you are going to be in trouble. And as I've said earlier, near the Earth's surface, that's going to be 9.81. And most of the time we're just going to treat gravitational field strength as being exactly the same as gravitational acceleration, which is why in your data book, if you look up g, the value g, it won't be given to you in newtons per kilogram, it will be given to you in meters per second to the -2. And we will talk about why that is the next video when I do Newton's second law. Okay, so remember, if you've got any questions, remember to ask me when you see me in class. Otherwise, just learn those definitions. That's the key thing. It's going to earn you lots of marks in the exams, I promise. Can be the difference between a grade, just learning some definitions. Okay, so any questions? Just ask.